Hello friends, in continuation of chapter named as structure of solids, today we are going to discuss the relationship between density, radius of unit cell and lattice parameters. Before that we will see that up to that point we discussed so many things about structure of solids. That means what are solids, then how constituent particles are arranged in a different arrangement, that is packing in different ways, one dimension, two dimension, three dimension. So packing efficiency also we discuss that if we have 7 different crystal system, and in that 7 different crystal systems, what will be the arrangement of constituent particle taking place, also how much space of that constituent that unit cell is occupied by, or number of atoms which are present in different types of unit cells, we have already discussed. So we want to study another important relation. That relation is used to understand that how lattice parameter, that means edge length and edge angles, are related to radius of unit cell as well as density of unit cell. Consider a cubic lattice with lattice parameter A. Right? A is the edge length. Remember, A is what? It is a edge length. Let rho is equal to density of crystal. Rho is what? Rho is nothing but density of the whole crystal. Okay. Then that rho, that is density of crystal, is defined as it is the ratio of mass of that crystals per unit cell, mass per unit cells to the total volume of unit cells. You know the normal definition of density. Density is what? Density is nothing but mass upon volume. So if you want to calculate the density of unit cell, then you have to take what? You have to take mass of unit cells divided by volume of unit cells. If you want to calculate the density of whole crystals, that is nothing but what again? Mass of number of atoms present in a one unit cells divided by total volume of that unit cells. Everybody understood? Okay. Now next important parameter is volume of unit cells. Volume of unit cell is denoted as A cube. You know the volume of cube, that is a cube, that is what? Actually you have to consider three sides. If A is the edge length, then you have to consider three sides of that unit cell. That means you have to take a cube of that edge length, A cube. Mass of each unit cell is equal to what? Rho into A cube. Rho into A cube. That means here what happened in this equation number 1, we have arranged the equation of density. Density is equal to what? Mass upon volume. Right? Mass upon volume. How we will see with the help of so you can see rho is equal to density is equal to mass upon volume. So mass is equal to rho into volume. So volume of unit cell is denoted as what? A cube. So mass is equal to rho into A cube. Everybody understood how equation 1 is obtained? Let suppose n be the number of atoms present in your per unit cell. That means suppose we have different types of unit cells, and with respect to that there are different capacity. That unit cell have different capacity to accommodate the number of atoms. For example, in simple unit cell there is only one atom can present. For body center type of unit cell there is a 2 atoms present in one unit cell. For FCC there are 3 atoms present in 1 unit cells. M is the molecular weight of that particular atom. A is the Avogadro's number. So how mass of each atom is calculated? Mass of each atom is equal to mass of that atom divided by Avogadro's number. What is Avogadro's number? 6.023 into 10 raised to power 23. That number is called as Avogadro's number. So mass of each unit cell is what? Mass of atom, you know, mass upon Avogadro's number. Then mass of each unit cell is what? That means how much number of atoms present in that unit cells. That number multiplied by that atom, mass of that atom divided by Avogadro's number. So n into m upon n, capital N. So that is called as mass of each unit cell. Equation, we will get a equation number 2. Now from equation number 1 and 2 we can get rho into a cube, that is what? Mass of atom. Okay. Is it clear? Mass of atom is what? Rho into a cube, which is equal to what? N into m upon n. N is what? Number of atoms. M is what? Mass of that atom, and capital N is what? Avogadro's number. So if you rearrange that equation, you will get what? A cube is equal to n into m upon rho into n, or A is equal to nm upon rho n, bracket complete, of its power 1 by 3. So in short, this, if you want to calculate the density, then again above equation can be rearranged. Rho is equal to z into m upon a cube into n0. So what is z here? Z is the atomic number of that atom, m is the mass of that atom, molecular mass of that atom, a cube is the volume of unit cell, and n0 is the Avogadro's number. If you have all 4 parameters, then you can get the density of that unit cell. Now if you want to calculate the density of the crystal, it is defined as ratio of mass per unit cell to the volume of unit cells, total volume of unit cells, where Z is what? Number of particles per unit cell, M is what? Atomic mass or molecular mass, and N is the Avogadro's number. If you have again all the parameter, then you can easily calculate the density of that particular unit cells. So density of unit cell is equal to Z into M. Remember this formula, Z into M upon A cube into N0 multiplied by 10 raised to power minus 30 gram per cm cube. That gives you the density of that substance. The density of substance is same as the density of unit cell. If the density of particular unit cell is same, then you will get the same value for every kind of unit cells. Okay. So on the basis of this formula, we will see some important numericals. Okay. So we will see first numerical that is given in your book also. I will just read that and try to explain. Iron crystallizes in BCC structure. Remember what is, you just see, iron crystallizes in the BCC structure if the length of unit cell, age is 286 picometer. What is the radius of iron? What is the radius of that particular iron? Just wait. Okay. So what is the radius of iron atom? In solution you can know that what they have given. Write down first data. A is equal to what? A is the edge length, and that is 286 picometer. Okay. In BCC, in body centered cubic structure, body diagonal 2r is equal to what? 2r is equal to under root 3 upon A, under root 3a upon 2, that is the formula of 2r. Okay. So, from the equation, rho is equal to what? Rho is equal to, just wait, here it is not given. R, that means radius of ion is equal to what? Under root 3 into A upon 4. That means you have to just rearrange. What is the value of root 3 into 286 upon 4? So, you will get 124 picometer. Problem is very simple, but you have to remember there the formula.